Malvertising is when a malicious actor pays for advertisements on search engines or online resources so their malicious payload gets boosted to the top, and it's used as a social engineering or deceptive scheme that might scam an innocent user into downloading, running, or executing malware. Now, this story that I'm about to tell you isn't strictly about malvertising, but it was a payload that could be found just with a simple Google search. Say you are a security researcher or an analyst or just someone doing some programming or development work, and perhaps you were to Google for a Python obfuscator. Now, you'd get your results, maybe some GitHub tooling, maybe some online resources that'll make it nice and easy for you, and one of those results, one of those online resources from freecodingtools.org had a little bit of an interesting issue. This is the online Python obfuscator from this freecodingtools.com website, and you could scroll down and provide your own code over on the left-hand side. I don't know, maybe do whatever we'd like, import OS, we could print out perhaps our OS environment username, and if we were to click run over on the top here, it would generate this obfuscated code over on the right-hand side. I'll copy and paste this out so we can take a quick look at it, and this is all of the output, and it looks pretty obfuscated, right? This is nonsensical to the average user or individual just opening up the code. It's not what we started with from our simple OS print the username. We do define, hey, maybe some Lambda functions, import some zlib libraries, decompress data that would be reversed base64 code, and if we wanted to rip through that in CyberChef or just do it from the command line in Python, we could do that. But that's not the peculiar piece to this story. If I were to deobfuscate this, and I will in just a moment, we wouldn't see anything out of the ordinary. It just looks like our import OS print the username. But previously, it would actually deobfuscate and include malware, malicious Python code. And the end user, the individual, the security researcher, the analyst, the programmer, whatever, using this tool would be infected with information stealing malware. Now, let me say, credit where credit is due, I got this tip from one of the researchers over at Phylum. If you aren't familiar, Phylum is the software supply chain security company. They're looking into packages, libraries, modules, pieces of code that might be available on online resources or sort of package repositories. Think like PyPy, the Python package index, or maybe Node, NPM, all the resources that might get pulled from it. Really interesting thing because they're actively looking for that evil, nefarious activity, even in code that developers might use. I don't mean to sing their praises too much, but seriously, they have some awesome visibility and just really cool stuff. You can find a lot of their latest research online at phylum.io, and they have some super cool blog posts on stuff that they're seeing out there. I will mention too, they just had a really cool article put out by Ars Technica about Phylum and all the great work that they've been doing about malicious code, malicious software, and things that are even just out on GitHub. So look, I'm sorry, I don't mean to be rambling, I just thought it's really cool, and Phylum is doing sweet stuff. So the real story here starts way back in January 19th, when a user that had recently joined the Phylum Discord server was sharing the fact that, hey, they recently discovered Python malware, presumably a token grabber, on their laptop. And they were just using a website, some Pi obfuscator, maybe piobfuscate.com, couldn't really remember. After some research, they had found Phylum's article, and they wanted to understand what was going on, what was happening on their computer. The conversation goes back and forth, and they dig into it just a little bit, and the user says, look, we found this odd-looking file, Windows Update Script.pyw, and they just wanted to dig into it. They shared the sample, they've got it up on VirusTotal, and then we're tracking just a bit more. They shared the source code, and we'll dig into that in just a moment, but let me go ahead and clarify, they drilled this down and were thinking, hey, we've got these options, piobfuscate.com and free coding tools piobfuscator. Continuing the conversation, they think it's this first one, that piobfuscate.com, but as they drill down into it, do their due diligence and detective work here, they are thinking, you know what, actually, I can't track down the malware that you just saw, but they could recreate it with the freecodingtools.org piobfuscator site. Now, the user is still thinking, look, it's gotta be from piobfuscate.com, and they include a picture, actually. They do some interesting stuff here. There's an imager link, and if we go take a look ourselves, we can see, look, this is their Windows Defender with some exclusions added for some locations in this executable folder here with runtimebroker.exe in the mix. Now, I'll admit, it's not super clear to me which of these websites was offering the malicious payload since they couldn't recreate it with that freecodingtools.org or whatever website now, but the user was thinking it came from this piobfuscate PyD. So this is the website for .pyobfuscate PD. I wonder if we can just simply paste the code that we were working with previously, and let's see if we'll get some malicious output. Again, this is just for a stupid example. Type in just for the sake of making some noise here. But if I scroll down and submit this, let's see what that generates for us. Scrolling down, here is our output. See, this doesn't look like what they had for their sample. That is still odd to me because Phylum was seeing some malware samples that had the syntax and structure that matched free coding tools and not this setup from this PyObfuscator PyD thing. Tracking back to our Discord storyline though, catching up to current time, because remember, this was on January 19th or so. But now, trying to go take another look at freecodingtools.org, it isn't spitting out that malicious code anymore. That is a bit interesting to me though, because I'm wondering, is it random? Is it, hey, if you're like the 100th or the next 1000th person to submit some code, then it will give you malware? Or has it just been fixed? Did they track down that malicious software was somehow being put in there and that wasn't intended and now they've corrected it? I don't know. But anyway, I want to show you this malware and I want to dig into it and we can have a little bit of fun kind of pulling the thread here on this. But look, before we do, I gotta say, hey, I'm trying my best with a lot of these videos and I'm trying to get them out as frequently as I can and keep sharing free cybersecurity education and practical hands-on training. The only way that I'm really able to do that is with a little bit of sponsorship. So if I may, please let me tell you about today's sponsor, N8N. It's workflow automation for technical professionals. When you want to tie together different APIs and you know when you need to slap some code in the mix, like Python or JavaScript, all with flexibility and scale. You can build complex automations 10 times faster and connect practically any application. Think Gmail, Slack, QuickBooks, Airtable, anything. And one incredible use case is for cybersecurity or DevOps. You can mix in GitHub, VirusTotal, URL scan, even MySQL or Postgres databases, anything you want. Or even just incorporate raw HTTP requests to get whatever data you need. I use N8N personally for a homegrown threat intelligence feed, and the flexibility and configuration is awesome. The full source code is available, and an N8N instance can be completely self-hosted, so you can even automate file system events or operations on your server. Seriously, if you are a technical practitioner, give N8N a try, and get creative with all the things you can automate. Build workflows and focus on KPIs, not APIs, and save time every single day. You can get started automating today in a free trial of N8N with my link in the video description, jh.live/N8N. Huge thanks to N8N for sponsoring this video. Alright, so let's get back on the keyboard and let's start to dig into this. I'm inside of Remnux, the reverse engineering malware Linux distribution, and I am going to open up a terminal. I've created a directory called Tsunami for this, and I'll explain that a little bit more, but I do have the obfuscated payload present in this directory. If I open it up with Sublime Text, my text editor, this is the sample that we were just looking at. This is what was spit out by freecodingtools.org.com, whatever, and this should theoretically just be our OS system print username, right? Now we could write some crappy code to try to unravel this reversed base64 syntax, zlib inflate it, and then see if we need to iterate through that and do it over and over and over again as we peel back the onions and layers here. Thankfully though, the great researchers and folks over at Phylum did share the script and syntax that they use to be able to deobfuscate it. And it uses some abstract syntax trees, so it's a lot smarter and a heck of a lot better than anything that I would be able to write. Let me go ahead and copy and paste this and we'll see it in action. I'll get back into Sublime Text, paste this all in, and this is basically what we need here as I clean this up because it will work with a obf payload.py and then spit it all out. Let me save this as deobfuscate.py. You can see I already have it staged. And if you drill down into the code here, you can see that they actually do try to extract or deobfuscate one layer about 50 times to a certain extent. They write it to a new file, deobfuscated, and actually, let's go ahead and store that as a variable. We can at least do some of our own writing here. We'll have a final layer that we will write to a file, and you know what? We could also probably just print it out on the screen. So let me get back to my terminal, and now let's try to run our deobfuscate script that should automatically pull in and read from our obf_payload. Let's see if this will spit out. Oh, I have a, whoops, Discord bad copy. Yeah, I've got to remove that last line there. Thanks. markdown syntax. All right, let's try that again here. Let's run the script, and there is our output. Just import OS, print OS environment username, just what we were using for testing. Now, the victim that we heard from on Discord did share the sample that they had in that Windows update.pyw file. I appreciate that VirusTotal actually tags that as JavaScript, and it has 0 detections. But it is on VirusTotal, and we could actually download that sample and try and work with it. Let me download it as a zip file here. We'll use the default password infected. Thank you, VX Underground. That's a joke. That's just the standard password for malware, right? Now, I have dropped that into our virtual machine. We have the zip file. Let's use 7-zip to X to extract that, 155.zip. It will need the password that we know is infected. And now we have the hash of the sample here, C688, whatever. Let's open that up in Sublime Text, and it is, just as we saw previously, that base64 data for the obfuscated code. We'll get back to our command line, and let me try to copy that big C6 hash and that file over to our obfuscated payload, since now our deobfuscation script should be able to read that and then spit out all the contents. Now, obviously, there is a lot more output than our stupid OS username print environment variable, right? This is just showing the bytes on the terminal, so let me see if I could open up our deobfuscated file in our text editor. And this is the exact same output that user shared over on Discord. You see that randvar 11616 whatever? Looking back in the conversation, we can see that Lewis over at Phylum did go ahead and post this exact script that he was able to pull out previously. So let me drill down into that in just a second, but I want to add a little bit more context and just another breadcrumb or a puzzle piece for our story here, because I got to chat with some of these Phylum researchers, and they shared with me they actually saw a sample just like this in one of those malicious Python packages being hosted on the official and real PyPy or Python package index some time ago in December. Take a look at this. Inspector, right? Hey, one of those tools to be able to look through the PyPy Python package index, and this was allegedly a NumPy premium module or package or library that could just be pulled into your own code. And obviously, it is this, again, obfuscated sketchy code. If I were to try and copy and paste all this, we could run the exact same deobfuscator script that we have. Let me get back to Sublime Text, and I'll go ahead and save this as the submitted malware sample.py from our previous rendition, and let me paste in all of this that we just got from that package. We'll save that as our obfuscated payload. Go ahead and replace that file. Back on our command line, let's run our deobfuscate script again. But interestingly enough, this still gives us some base64. It didn't finish working through all of the layers or the piece of the onion that we had to peel off, right? This is kind of cool because we could dig into that deobfuscator script. They have some simple functions to be able to find byte strings and then extract everything out. And of course, the deobfuscation real component that we were chatting about, but the amount of layers that we cruise through might differ. I believe this took about 127 iterations. And again, that's just for me chatting with Phylum. And hey, they already cut through all this. So let me get back to the terminal, try and run that one more time. And there we go. Now we have some info here. That spat it all out on the command line. But remember, we did write to our file, deobfuscated file. And look at that. We have a script URL variable being set to that domain, freecodingtools.org, files TSU script, presumably Tsunami as something we keep referencing, and we'll drill down into the real malware that we saw just previously, but I'm super curious about this URL. Remember, we were just previously over here on our Free Coding Tools online Python deobfuscator. There's that URL up top, but if I were to try to go to the strict URL of freecodingtools.org/files/tsu script.py, that gives me a 404 right now. So that is no longer on the website and has been removed. Again, just makes me wonder, hey, did they clean this up? Was it updated to no longer be malicious? Or are there just some specific certain circumstances where this payload is delivered? At the very least, this does put together some puzzle pieces, and we lean more towards, okay, it's definitively freecodingtools.org that's potentially serving malware at some point, rather than that pyobfuscator/pyd website. So if we look back at that malicious sample that was on PyPy for our NumPy thing, whatever, you can see there's some PowerShell syntax to download that malicious script when it was ever available. And then, hey, use subprocess, fire off that PowerShell command with no window, a little bit stealthy, a little bit dumb, with Python W to execute it. Odd, peculiar, and again, looking like a real Python package, NumPy Premium, going ahead and installing all of this. So let's make an educated guess here. The malware that we're looking at with the other sample that we did deobfuscate is actually tsuscript.py, the tsunami info stealer that we'll dig into. Let me get back over to that other tab, our submitted malware sample, where we had some random value and then imports for all the stuff that it might be able to do, and we'll get to scroll through this. Now, I realized, look, it's Python, it's just a scripting language right now that we can read pretty easily. We've got the source code, no special tricks, no secrets that we'd have to cut through assembly or use Ghidra or some debugger. This is pretty simple, easy stuff right now. But look at how everything ties together. We have this, hey, couple application data, folders and directories that we retrieve, a payload name for tsunami in the folder and path, and then, hey, there's that runtime broker that we saw in the screenshot. I'll zoom out just a little bit because I know there's a lot here, but look at this install folder in roaming app data and the install folder for applications, runtimebroker.exe. Look, that is exactly the exclusions that we saw in their screenshot. And I'm curious about this download URL going to Dropbox with a funny meme compilation.mp4. Okay, sure. Clearly not an MP4 file. Is this thing still alive? Is this on the internet? Let's go back to our web browser, try to enter that in the URL here. No. Okay, Dropbox can't see that either, and that's taken down. But it has the payload script embedded as another long multi-line string here with a couple utilities and some info. But interestingly enough, all of that is present in this script just as well down below. However, there's an obfuscator there that will obfuscate the script given the function with a random variable, replacing that static value with a genuine, real random value. And then it does its setup obfuscation with the exact same kind of capability that we've seen just previously and looping through it over multiple different layers. Oh man, that's wild. And it builds out the complete output, spits it all out, and ooh, a couple other interesting functions here, like staging scheduled tasks. There's persistence. Here is a persistence mechanism, an implant or a foothold, whatever we want to call it, to actually make sure, validate we have potentially the ability to keep running this code even later on if the user logs out, logs back in, reboots their computer or whatever. Now we download a Tsunami installer, retrieve that URL that we saw from Dropbox, extract the payload, and ooh, this is kind of sweet. Execute the payload with UAC, user account control, right? To have elevated admin privileges on the victim computer. And I like the way they do this here. C-types with just a simple Win32 API call, shell execute, but using run as to stage it with more of those permissions there. Back to the payload that they saw just previously. That has a little bit of Boolean value there. Execute payload with UAC. And then it checks everything that it has already staged, nice and easy convenience functions for. And they have like literally like the exploit output where you use square braces and plus signs to look all neat. Oh, wow, that's slick. It's obviously evil, right? It's malware, right? That's not good, but it's cool to see it coming to life. Did they have anything else special in the embedded script? Create the task. Oh, that must be, wait a second. No, there is more in here. This is really sweet. Let me pull this out. I want to grab all this and read it with regular syntax highlighting, not just all yellow text. Copy, paste into a new tab here. There's our rand variable. There's our imports, some of the data stuff that we saw just a moment ago, but there's that isAdmin function. That's kind of cutesy. That'll determine whether or not we'll pop the UAC prompt, right? And then add Windows Defender exclusions, or exceptions in this case. More PowerShell to add what we just saw, so antivirus won't scan these malicious files, runtimebroker.exe, the downloaded Dropbox executable for runtime broker, and it does this and stages a scheduled task. That's pretty wild to see. Let me turn word wrap on super quick. This is just PowerShell syntax, right? Nothing special here, and it's totally outright. Now, we've not seen the obfuscated component. It's just something we can read super duper easy, but it worked. There were 0 detections on that Python script, and I don't know, if you fool the user into clicking UAC prompt just as they log in, probably something normal. I don't know, they would think whatever computer's doing whatever it needs to do with a runtime broker. Yeah, that's wild. Wait a second. Exception paths are interesting. It has the Tsunami installer, a client, and then an XMR rig miner or cryptocurrency miner. Faking it as Microsoft Edge. Oh, you gotta love to see it. Wow, that is wild. Okay, so we've got some more of the puzzle pieces, a little bit more of the breadcrumbs here. That's the Python script, but we're curious what would have been that runtimebroker.exe that came from our stupid Dropbox link, right? We can go see if there was any more conversation about that as to what the user had seen over on Discord. Now, this is where it gets even more wild, though, because, again, chatting with the Phylum researchers, they let me know, hey, this was a conversation that got to be had over on the real legitimate Python Discord server. So one of the administrators here, I think, or a helper, they note that, look, your detective work is correct. That website is definitely malicious. Would you mind removing the URLs so that no one else gets infected? And there's more conversation that follows. Some users begin to discuss this more. Hey, what do we do now? Do we go ahead and try and get this taken down? This is February 15th, so pretty recent, maybe 2 weeks ago now. And I like that they acknowledge this here. Look, the issue is a lot of people use this site. It's literally one of the top results listed on Google when you try and search for this thing. It's one of the top results. Think about how many people are infected and how many will get infected. So thankfully now we've seen it cleaned up, but we can't say for sure why. Anyway, getting back to the tactical stuff, that initial user, the first victim we saw from the Phylum Discord server, did share on VirusTotal the executable files that were downloaded, staged, and added into their startup files. This is presumably the runtimebroker.exe, added here I think as .dll, but I believe it's the same, and only 4 antivirus detections noted on VirusTotal. Couple crowdsourced Sigma rules firing off. Looks like the PowerShell syntax to add to the exclusion list. Of course, execution from a temporary folder. Firewall rules being added, and some other interesting shenanigans, like Tor exit node data. So I'd love to dig into this. We could get into more of the details, check out the behavior, see some other results. But look, all this is in the mix. Hey, noting Tsunami, noting virus.exe, malware lol. So odd occurrences. But this is a flat executable, right? It doesn't look like a .NET assembly or anything odd that we might be able to crack open with ILSpy or .peek or others. So just for the sake of time and being able to show you this in a quick and easy way, I will download this and we'll go ahead and kick it into some online sandbox to do the dynamic analysis rather than droning through Ghidra or IDA, trying to disassemble and make some static analysis sense of this. I'm sure you all know I'm a huge fan of any.run as some sweet cloud online sandbox. They just also added this threat intelligence feature, and that's pretty awesome. Anyway, let me dig into this. I will create a new task here. This is fine to be a private task. I'll set this to Windows 11. I'd like to drop it in the desktop just so I can see it, and we'll crank the maximum time up here. And let me drag and upload our file. Okay, that is placed there. I'll go ahead and click Run Private Task, and we'll see what this does fired off in action. This is a hefty file, by the way. I think like 50 megs, so it'll take a little bit to get this thing cruising. But while that's happening, I guess we could attempt some static analysis, right? Okay, so now I have that AB76 sample here, and of course, file on it. We'll just say, look, that is a portable executable for Windows. What I could try to do is just stupid Dumbo strings. I don't know if that'll clue us in if it is a Python script, maybe compiled. I can look for any Py notions here. Nothing super worthwhile. Let me try to run foremost on it, see if it gets anything out. It is 50 megs, right? Anything in the output directory? Ooh, an HTML file? What is that? I want to view that. Oh, hang on. Sorry. Looks like any run is also getting started and kicking stuff up here. So that has executed. I don't know how well you'll be able to see. I can move my face here. I guess I'm in the way. Okay, it is cruising, trying to make some connections out to some oddball places. Seemingly nothing from our sample quite yet. But there was one threat noted. Service host? No. What is this thing doing? Drops an executable immediately after start. Queries computer name, checks languages. Does it run it? Does it do it? Okay, let's go back to our static work. I do want to know what this HTML file is. What the heck? I don't know what I'm looking at right now. Why is this here? If I open this in a web browser, is it gonna like fire something off? I want to do it. What do you think, Firefox? Yeah? Not your bag? Okay, so we're going to ignore that. What is in the DLL? Is that anything interesting? Oh, there are a lot of DLLs, presumably. What are all these? Oh, they're all .NET assemblies. Look at that. We could try to cruise through them. They're all meant to be run on Windows, so I feel like I'd have to use like ILSpy CMD. Like you can use ILSpy CMD here in Remnux, like we have that capability, but I like to do it in Windows in that case because it's going to be doing Windows specific stuff, right? Let me try to stage that, but I also want to go see what that other file is because we saw a couple of them. There's an XMR rig miner that we don't care about, our Tsunami installer and the Tsunami client. Did those, I don't know which one we just saw. We did have another link that we could explore though. There was one other virus total suggestion there, and that is another runtimebroker.dll, but goodness, that one has about 30 hits. And that does oddball stuff. Let me see if we could try to make sense of this one. This has even more Tor relay router things, and maybe a Discord token stealer. So is this the stealer that we're actually digging into? We can try and download this just as well, and we'll see if we can make sense of that. I do want to press the easy button with any run one more time. So let's kind of stage this all again for this other sample. Let me try and upload that. Okay, this is the C2FB hash. Let's see if that, oh, I need to stop the other one. Dang it. All right, that is staged. How about now? Looking good? That's about 35 megabytes from what Virus Total said, so a little bit faster to get that cruising. Maybe we'll get to see this one do something. I do want to crack open the other one in like Ghidra or something to see if like is debugger present or some stupid anti-analysis stuff getting in the way. Wait, oh, what the heck? This needs .NET desktop runtime to install? Okay. Is it a .NET like the same assemblies that we would have seen previously? Let me try and run that. I will just go ahead and install .NET. Like there's nothing wrong with doing that in the interactive sandbox. Okay, that is downloaded. Let me see if I can open that up. Okay, I managed to accidentally open it 3 times and open Firefox. So there are a lot more other process events in this case. Okay, finished installing. Good. Now, can I run my sketchy executable? Let me see if I can double click this here. That will fire. Whoa, look at it go. Okay, let me move my face. Check this out. We have our PowerShell exclusions being added in that we just saw previously from some of the other intel we were digging into. A whole lot of those. Add MP preference over and over and over again. Shelling out to PowerShell. Nothing special, nothing fancy there. NetSH firewall additions. Could we see that in like strings, or is it obfuscated or tricked in some way? What else does it do? Those are all the process things that it fires up, but what do our connections look like? Now we should have a lot more going on because runtime broker would fire, smart screen in the way, Firefox from when I hit that earlier. Where's runtime broker? There it is. Whoa. Those are some sketch country IP address domain things. And there's our MS Edge that I don't know if I can trust if that was the MS Edge or the real one. Oh, reputation is a question mark. Maybe that was one that it staged. What is that doing? What is that sending? Are those just, oh yeah, those don't matter. Those are flat. What is runtime broker doing connecting to these other things though? Is it sending any data? It's taking a little bit to load. I'm gonna let that keep going. What about here? No, we'll wait. We'll keep waiting. Runtime broker not doing anything else. DNS request. Do we see anything else peculiar? I think there's a lot going on, and like any run is just kind of, hey, trying to keep up right now. Nothing seems to be loading or pull it back from me. But the PowerShell ones are interesting. What is this? When it runs runtimebroker.exe, SOX port 9050 with a data directory of the Tor data. Okay, so it must be doing something like literally genuinely through Tor, but we could do some neat stuff with that, could we not? Like, again, thanks to having an interactive sandbox, I think I could open up Explorer and go navigate to that directory. Maybe see if we could get any sweet Tor data out of that. So that is in local app data, right? In temp and Tor data, just there. Ooh, there's some interesting stuff like the state file, right? That might, does that tell us anything like super cool or worthwhile? I want to open it in Notepad and we can see the Tor state file when things are ran, circuit build time bin. I don't know a whole lot of these, truthfully. I need to get a little bit smarter on how that all comes together. But we could see nicknames and different IDs. Free lunch. I think these are all the nodes that it's hopping through, but I might be just completely naive and unaware. I need to get schooled, and please let me know in the comments if you know more than I do, which I'm sure you do in this case. Cache certs, cached micro description census things, keys. Keys doesn't have anything in it. That folder is empty. But it's definitely communicating over Tor. And I wonder if the info stealer is just funneling it out, exfiltrating it through Tor. I'd have to probably dig in a little bit more. Can we see that in the network stuff though? I really want the threats to load from any run. I want to see what sketchy stuff you're seeing. Let me let that go and we can try to see how this looks in our static analysis if we want to dig into that. Let me see if I can drag in that new sample, C2FB. That is that the full thing? Was it only 3 megs? No, I think it's 35. Let me try to drag that in again. Okay, there it is. C2, now 35 megs. Obviously checking that one, it is still an executable for Windows. Let me move the previous output directory to like the AB output. And then let's do another foremost to see if there's anything we can extract out of that C6 option. Does that have anything in the output directory? No. Interesting. Oh, I ran on C6. I need to do that on C2. Dang it. I know I just deleted that sample because I'm moving too quick and it's 3 in the morning. That's fine. Let's try that again on C2. Too many SHA-256 hash names, stuff, whatever. Output. We have bitmaps this time and more DLLs. Okay. What is going on in those bitmap files? What are these? Just oddball icon things? Nothing worthwhile, I think. How about those DLLs? Are these all the same as the others? No, these are much bigger. These are much bigger, it seems like. Let me run file on these. Okay, so a lot of .NET assemblies again that we could try to rip up, and just an executable. Maybe we could dig into Ghidra if we really wanted to. Let me try to bundle up all of these DLLs that we're seeing from the AB sample and this C2 sample, and then put them into the Flare VM, so like Windows analysis side, and then try to cruise through though with ILSpy CMD, just so we can get a quick cursory look out of all of those, because there are multiple different .NET assemblies. Maybe that'll be a little bit better than just like one at a time in .peek or ILSpy. And anywhere is still going. It's about to finish. Did it pop any other executables? I don't think so. Oh, no, there's the MS Edge one. That one is interesting. What does that con host do? Ooh, it tried to enumerate with CMD the number of cores and get some other deets. And it's all XMR rig, right? You can see it down below, just barely. Yeah, that msedge.exe, as we saw in the Python source code, is clearly the crypto miner portion. 100% malicious on that, looking good. Show me the threats, load this thing. Okay, now the connections and DNS requests and everything is coming through. So let me go find our oddities. You can see the XMR pool getting called out to. Maybe that's why it was taking forever, because it started mining crypto in this virtual machine. Okay, cool. Runtimebroker.exe is going to be using a known Tor exit node, as we saw. Okay, and we got some of the IP addresses. That's some details. That's sweet. Stream data. Can we see any of that? Does it show it to us? Or is that all encrypted when you use it through? That's still taking a little bit of time to load. What else does this thing do? Tor capability, another Tor capability. Different traffic groups. XMR coin miner usage. So that must have been the installer for some of this. Where is it an info stealer? Is it going to send some stuff through Tor alongside the cryptocurrency miner? Okay, now the stream data is loading, but all of that. Oh shoot, we can see a domain. What is that? That's not an onion link though. What is that coming from? I would have expected if you're using Tor, you're going to be, well, I guess it is just to go through the traffic, but I did not expect to actually see a domain pop out of that. I thought we would see like some spooky dark web v3 onion Tor hidden services URL. Is there anything else that's interesting here? I want to like expand all these and just be able to grep for weird stuff. There's so much here, so I'm going to be scrolling through this for a long time, and I don't know if that's worthwhile. I just want to go look at that domain now. Man, look at how far down the rabbit hole we've fallen from this free coding tools, Python, to some of these. Is that even a thing? Like, is it only going to be recognized through some Tor domain exit node DNS thing? I don't know. Okay, any run still gave us some pretty cool insight, but we should go back to playing with some of those DLLs that we were curious about, right? Can I bundle all this up and make a directory C2 hash DLLs, and I'll put all those in there, and then I want to get the AB DLLs just as well. So let me move those into a new directory, AB hash DLLs. That's fine. And then I want to make this an executable or a little archive, right? So we'll call these weird tsunami malware DLLs. That's fine. And now let me go fire up that other Flare virtual machine to get that into Windows. Okay, I have so much crap on my desktop. Pay no mind. Do not worry about it. Can I just paste this in super easy? All right, here, I got it. So let me go and extract to weird tsunami DNLs. Perfect. That's looking good. Let me open up Commander. I'll get to my desktop. I want to move into the weird tsunami DLLs. So let me get to that AB out. Shoot, did I? Oh, I don't think I even put the right files in that. Okay, I've got that staged here now. I should be able to extract this just fine. Weird tsunami DLLs. That spit out. Perfect. I've got those folders staged. Let me try to stage this in like Sublime Text then. Can I LS all of these? Now let me replace all of those with a new line, and let me try to do ILSpy CMD. I hit Control-Shift-L on my keyboard, by the way, so I could do now the AB hash. Let me grab the full file name, but let's do a .cs at the end, since it will end up being C# code at the end of it. So I'll paste all this. Oh no. There we go. Okay. If I just paste it one at a time, it seemingly worked just fine. So now we'll get all of that carved out for each of those DLLs. We can see the pseudo compiled, decompiled bytecode, and that will give us some C# that we might be able to explore. And we'll do the same thing for our C2 hash ones. We can kind of deconflict what is normal and what's not. Are there any similarities? Are there differences between each of them? Or we could just kind of explore. Let me do this for the C2 DLLs. I'll stage that, placing new lines, Control-Shift-L. Same setup here. Start to carve these out. This one is going to take a little bit longer, right? Because it is all huge files. Like those were megabytes in size. But now I should be able to at least go take a look at the C# ones. Can I open these all in Sublime Text? I should have put these in another folder. Dang it. Let's make like a decompiled. Now I can use Sublime Text and just open a folder, decompile that, and now we can look through all of these. There we go. There's some C# to explore. Okay. Hidden Wallet. This is .NET Tor, presumably, a library for the essential Tor features in .NET Core. So, okay, this is likely, hey, the capability as to how they are using Tor within the code here. This is all a library, right? This is all just capabilities for the functionality of the application, not what it will do in its own procedural like main function, though. So I don't know how useful all of this will be to see what exactly it does, but we did just get to see that in the dynamic analysis. At the very least, it's kind of cool to be able to extract a lot of this code out, though. Is there like any main function in any of these? I feel like it's all just the structure. What else do we have in these different DLLs, though? What is all this? Newtonsoft JSON schema. Yeah, JSON.NET for working with JSON objects. Again, more libraries likely used. Asynchronous coordination, more asynchronous programming in .NET libraries. A double-ended queue. Okay. What is this? Cyroot, .NET library for retrieving and changing all special Windows folder paths. GitLab known folders. What is that? I want to try to go to that URL and see what we got here. Interesting. Library retrieves the paths to all the special folders available on Windows systems, including not exposed by environment get folder path. Wild. That's some C# tooling if I do say so myself. What else do we got? System diagnostics debug, system drawing. Okay, those are probably just boilerplate, right? You see those all the time. But it's interesting that these are all bundled into the executable. I mean, they have to be, right? If they actually even want to use them, that it wants to be a static, fully all compiled in one location binary. Is there any other weird stuff? Like the .NET Tor one is interesting to me. What else do we have? These all look like defaults, system capabilities, XML, LNQ, reader writer, Xdocument, Xassembly, system, .NET assembly. So that's all probably boilerplate. How close are we to cruising through the C2 sample ones? Okay, that just finished. So let's try to move all those into another directory. I'm sorry, this has turned into a long video. You know, I start to have fun though when we get to dig into these. C2 decompiled, select that folder. Now there's a lot in here. What else do we see? A lot of imports in this. Bouncy Castle for .NET. What is that? The Legion of the Bouncy Castle? That sounds sketch. Bouncy Castle Cryptography API. Okay. We can Google that thing if we really wanted to, but I'm assuming it's just crypto code. Yeah. Okay. I don't think that's malware. Not gonna lie. I think that's just genuinely like tooling to work with crypto things in here. C# Discord webhook.net. That's where we get to some good stuff. GitHub, a little C# Discord webhook. So this is just speculation, right? But we got Tor in the mix. We've got Discord webhooks in the mix. We never got to see it like genuinely exfiltrate anything, but this is weird. If you're using .NET Framework, you need to add Newtonsoft, so that's probably explaining why that was in there. Probably just C# code to be able to send Discord stuff. Again, we could scroll through all of this code, but it is just the functionality of the library. That's still kind of cool to see, especially in the Discord component there. Hidden wallet, there's our .NET Tor again. We'll keep cruising. What else is here? Serviceable, okay, Microsoft working with SQL Server, SQL databases, Illusory Studios, HidSharp. What is that? They have a link. Illusory Studios sounds kind of weird. HidSharp is a multi-platform C# library for USB hardware devices. Is it just gonna like pull out attached devices? Because like I still get InfoStealer vibes, not gonna lie. Libre hardware monitor, get temperature sensors. Let me speed run through this. I'm sorry, I feel like I'm dragging and we're getting into boring stuff. These are all the same ones that we saw in just the other sample. iDebosable, asynchronous stuff. Yeah. SQLite Core. So I would think it would use that to extract from databases regarding, you know, yeah, the capability of an InfoStealer, steal stuff from browsers. These all look like real .NET things again. So nothing super good here. Well, hey, you know what? This video is already crazy long, and boy, we have already fallen down the rabbit hole from the story piece breadcrumbs of, look, some strange Python obfuscator really just churning out malware, stuff being found on PyPy, like legitimate, malicious, rogue, and nefarious packages, libraries, and modules that could be installed, to then, hey, track down this sample little tunnel data through Tor, and then, hey, slap up a crypto miner and try to pull out some C# libraries. It's just, there's a lot to it, but I think it's a wild story and some cool, fun things to learn. I thought that might be a neat thing to drive and drag us through for the video. Thank you so much for watching. I hope you enjoyed this video. And look, seriously, please do give some love to our sponsor. If you haven't seen N8N before, it is incredible, and you could pretty well hook up some stuff that could funnel and find even just strange, malicious Python libraries like this, or other malware with some cool threat intelligence and cybersecurity, DevOps, DevSecOps purposes. Lots of sweet stuff with N8N. Please, please, please show them some love. Link in the video description. Hey, this was a blast. Hope you enjoyed this long form video, and I'll see you in the next one.